In this video, we will learn to use a membrane matrix keypad. You should already be able to use GPIO pins as inputs to read the state of buttons, understand how to declare and reference arrays, and understand how to use for loops. For this tutorial, I'll be using a 4x4 matrix keypad, but the approach can be used for a matrix keypad of any dimension. You might just need to figure out each wire leads to. In the case of this keypad, the wiring is as follows. There are 4 pins for each of the columns and also 4 pins for each of the rows. Later, when we connect it to the Raspberry Pi, to avoid confusion, I will connect the row pins to odd numbers, GPIO pins, and the column pins to even numbers, GPIO pins. The keypad has no internal circuitry. For the approach, first, we will attach a matrix to 8 different GPIO pins. Next, we will set 4 column pins to output pins and set the output pins to low or 0 volts. We will set up each of 4 input pins with pull-up resistor. We won't need additional physical resistors as we can set it subdirectly from the program. Since we are using pull-up resistors, the input are set high. We will detecting the input when we pulled low. Thus, when the button is pressed a column at a low voltage, we'll hit one of the input, pulling that input low indicating which button has been pressed. Well, this almost works, but it flowed, and here is why. Let's say button 2 is pressed. Then, low voltage as pin 6 will be read by the input pin for the first row. Unfortunately, pin 1 has no way of knowing which of column is pressed. At best, input pin 1 can say that either 1, 2, 3, or A is pressed. But since all columns are the same voltage level, it doesn't know where that voltage reading came from. With this consideration, let's fix our plan. First, let me instead set all the output pins high. That means if any button is pressed, nothing would happen as the input are already set high. Now, here is the key change. We will set the output pins low, one at a time, and cycle through them extremely quickly. In this way, when a low is detected, we will know which column is picked, as only one column as low at a time. We are now ready to start writing the Python code. To start with, when dealing with GPIO pins, we must import the relevant GPIO module and use set mode to indicate how we will make reference to the pins. The numbers, letters, and symbols of the keypad can be stored into dimension array. Later, we will reference each element by its row and column numbers. Also, Nano is coded the hash and everything after it colors red because it thinks that it is a comment. This is a mistake. Nano's hash line in a string will not be interpreted as comment, so just ignore this area. Two more arrays are used to store the GPIO pins in rows and columns. Using a for loop, each of the four outputs is defined as set high. The four row pins are set up for a for loop, and each is defined pull-ups pins with a pull-up resistor. Our program will continuously loop forever, waiting for the input keys be pressed. Because of this, we should try to use except statement. In the try block, we have the never-ending loop where we are placing our code. This will keep on going unless there is a keyboard interrupt that will until someone press Ctrl C. At that point, except block will run resetting the GPIO pins to the default values, and the program will end. We set in our modified plan that we will need to set each of the output pins to low one at a time. This for loop goes through each of the output pins, first setting up low, checking each of the input returning back to high, and moving out to the next output pin. For the input, we will also cycle through each of them, but for this case, we will use if statement to check each one of them. If then inputs reads low, it must be a button pressed, so we will print the bottom label for row I, column J, using the matrix variable. We're almost done, but this code will print buttons values as long as the button is held down. To prevent the button outputting the same key multiple times, a while loop will start after bottom is pressed and will continue so long as the bottom is held down. In this way, the bottom value is printed once. The pass command here says do nothing. It's just the Python knows what to do in the loop, which in the case absolutely do nothing. Let's take a moment and look at the wiring. Our four output pins and go directly into our matrix. For our four input pins, they will go first to our breadboard, pass through a resistor, and after which, go into a matrix. The only reason we include the resistor is just a measure of precaution. If you're not being go with the safety, you can go with all 8 pins directly to the LED matrix, and everything will also working fine. Let's make our program to a try. Press 1, press 2, press 3, star, hashtag, A, D, B. Sometimes it comes with double letters or numbers. Then I'll hit 6 and I get it hit doubled. To deal with this, we can add some wait time. We put time sleep and then we can avoid those double inputs. That's all for this tutorial. Thank you and good day.